Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 28 of NL Math Man Math Help Streams. We're here, holding down the fort here in the midst of our social distancing measures, keeping productive, you know, getting courses done, completing credits, finishing programs, you know, helping people get some education, some book learning. It's good stuff. Or in this case, screen learning. Like, does book learning, does that imply that it has to be from a book? Like, say the format was different, right? Say you watched it in a video, right? Like you're doing now. Is that book learning? Right? Is that a good, you know, it's an interesting point, right? It's no longer book learning if it's a virtual book, right? Or is it? I don't know. It's an important debate to have. An important debate for exactly nobody, is what I'm saying. Um, over here now. There we go. I got it right the first time. Look at that. I'm getting used to it. It's stage right, you know. Over here, we've got a very nice picture today. Oh, what a good one. This is Smokey showing off how to be a good dog. All right? The best way to be a good dog is to make sure you're directly in the middle whenever anybody's trying to do anything. Right? It's well known. It's just that's the beginning lesson in doggy obedience school, I imagine. Is that, you know, whenever your people are doing something, you got to get right up in there, like right up in the center of it. So over on the side, they're sort of cropped out to expose to protect the innocent. Um, you can see my father, who was working on this. I can't remember what this wooden box was for some project at the cabin. This might have been like the top to a landing of stairs, I think, or something along those lines. But anyway, as we see here, while he's building it using the tools in the sort of top middle, we got little Smokey. Little Smokey come over and get right down in center. Of course, had to be right at the part that people were paying attention to and working on. That's the best spot, right? Because that guarantees you're going to get sort of rubs and pets and people talking nice to you. This goes to show, right? They never get a harsh word said to them ever, except like, I mean, if they were like, you know, not sitting down and healing when a vehicle's coming by or something, I mean, they'd get snapped at them, but they're good for that. So, as you see here, he's not afraid to afraid to get right out in the way. Um, and today's title topic for my rambling banter, we see here willing for grilling, because that's describing me. If we look above in this picture, directly above me, we see the bottom of a quite a nice charcoal kettle that I bought my parents uh, and brought it to the cabin. Although, I mean, to be fair, I use it pretty much every day I'm out there. Like I'm always using using charcoal to make to do my cooking. Yesterday, I was talking a bit about some of my like mother sauces that I make. Sauces that I've learned to do. Recently, well, I say recently, like the past 4 years, I really tried to expand my knowledge about barbecue, like proper slow cook barbecue. Like when I say barbecue, I don't mean like what some people would mean when they say barbecue, which is like grilling frozen burgers on a propane grill, right? That's not quite what I mean by barbecue. When I say barbecue, I mean like low and slow with charcoal and lump hardwood. It's good stuff, right? And right above me here, right here, you see this. Well, it's an old like Dirt Devil box, I think, but it's filled up with some chopped up bits of alder that I chopped down. We had to clear some brush out by the cabin, and a lot of it was alder. And you may know, or you will know briefly, that alder wood is actually a really good wood for smoking. Now, granted, ideally you should be removing the bark, right? But you know, but you can't use resinous wood for smoking, right? Because resinous woods sort of give off, the fumes from the resin and all this stuff like splatter and all those kind of things. Like you don't want any wood with a lot of sap into it. But alder is a really good one actually, and that's one of the only ones that we get growing, around these parts. So I harvested and sort of dried out some alder. There's quite a lot more than that what you see in this box out there, but there's some still left there. Today though, I'm not out at the cabin, not anywhere near the cabin, unfortunately. Although if I could get internet at the cabin, boy, that'd be something to look into, right? Do my distance teaching from the cabin, boy, that's living. Um, but I instead of going out in the woods and getting stuff, I ordered from Canadian Tire. But I have heard that it's in. So I've got some charcoal and some lump hardwood coming. I got some hickory, some apple. Oh boy, it's lump. It's lump hardwood too, not chips, right? Because chips burn too fast. They just go away to nothing and then they're gone. Right? Lump hardwood will smolder and smoke for a lot longer, give you a lot better flavor. So I can't wait now. Hopefully this weekend. Hopefully it's going to be nice. The weekend, I'm going to break out the charcoal kettle, slap some, do a snake method, what we call it, snake method. Wrap the coals around the edge of the grill, put some lump hardwood on top of that, light one end of it, and then just sort of let it burn all the way around. Gonna do some. I don't know what meats I've got. I think I got some. I think I've got a pork shoulder that's been in my freezer for like 6 months or something foolish. But I'm gonna break that guy out, and it's gonna be great. It's gonna be good to get. Maybe if there's any left, I'll treat you to a glimpse of it on Monday on my stream, if we have any of the food left over from that. But yeah, I've been rambling now for about 6 minutes or so. So I think it's about time for me to launch into the math for the day. We're gonna do finding percent of a number and converting currencies in units. We're going to do that first. I know it's a pretty common topic, but it's a rather big topic for a lot of the courses that I'm teaching here. And I do have some students doing those right now, so I'm going to start off with that. Then I'm going to go into a little bit about some geography, actually. It's from a science course, but it's kind of mathy because we're going to be talking about interpreting latitude and longitude, what those mean, and then how to draw a line graph. That's going to be specific to the Science 2100B, to an activity there, but it is still general skill that does come up in a lot of different courses, especially the graph drawing. Oh, hey, Kevin. Good morning. Let's see. Hello. Do you have some advice for algebra? See the problems out of my book that I have the insight, just don't know the math rules. Well, sure, sure, yeah. How about I'll tell you what. Actually, it's a really great question for right now, because when I get into this first topic that I'm going to be talking about shortly, I'll spend put a bit more time into talking about the algebra rules that underlie them, because those are the most fundamental and important skills in a math program for sure. Okay. So let me pop over to my working display. Here we go. Center up my paper a little. Nice. Perfect. So what I'm going to get into first is finding percents of a number, converting currencies, converting units of measure. Yes. So number 6 on this activity I wanted to start with. Let me zoom on in here. Yes. So I'm going to have to zoom out a bit so we can actually see it. Price of a box of 18 coffee K-cups goes from $11.99 to $13.49. What is the percent increase on the K-cups? Okay, so to find one number as a percent of another, we always have to divide. Right, so this is math 1102A unit 1. This is going to be number 6. Oh, let me zoom out a little bit. I'm not quite getting my whole sheet in the shot. There we go. So number 6 then. So the price of that box goes from $11.99 to $13.99, $13.49. What is the percent increase? Okay. So to find the percent increase, well, to find one number as a percent of another, you had to divide, right? So what we're going to do now is first I need to find out what the increase is. Well, to find the increase, of course, is going to be 13.49, subtract 11.99, which I could do out here just in long form. That's going to be $1.50, of course. right? But now I want to find this $1.50 as a percent of the original, right? So say I'm going to go, to find it as a percent of the original, I'm going to go 150 divided by 11.99, and then that is going to give me 0.125 or 12.5%. So it increased by 12.5%. Okay? Let's see. It's like if you have an equal or a not equal symbol, it means they are in equilibrium or it's greater or smaller. Yep. See that if you want to get rid of fractions, you can find the common number. That's true. Yeah, so common denominator. Yep, that's right. Or the lowest common multiple, we would say. Do it times the counter and all the other numbers and divide it. You can do this because the relative for the distance between the numbers stay the same. Um, hmm. I think what you're asking um, is, say, if we were converting fractions. Let me just put this sheet aside for a second. So I think what you're asking is, say, if we had like, I don't know, 2 over 3x plus, I don't know, 1 over 4y plus 6 equals 0. Say this is an equation of a line, right? And I think what you're saying, when you mention to get rid of fractions, what I could do here is say I want to eliminate all these fractions here, right, to turn this into what we call a general form. But for the question you're asking, what form it's in isn't super important. But say I wanted to get rid of both these, everything else still has the same distance relatively. Yes, okay, no, I get what you're saying. Yes, absolutely. Absolutely, that's right. Right. And one reason we can do this is because, like, an algebra equation are like balance beams, basically, equal signs. So equal signs are like balance beams, basically, right? So what we do to one side, we can do to the other. So say we had like, you know, say this was a scale, like so. I don't know. I'm not drawing out a super great scale here, right? But say we had like, I don't know, 3 weights over here, and we had three. Say that these were equal, right? If these are balanced, they're equal, right? So if we want them to stay, if we want to do something to change it, but to keep them balanced, then we had to do the same thing to both sides, right? So say if we were to, um, say we were to add one extra green weight over here, now all of a sudden this side is going to be heavier, right? So we would have to add a green circle weight over here too, right? So if we add, say we added one green circle to one side, we would have to add a green circle to the other to keep it balanced, right? Or let's say we had another situation. Can't make the denominator equal because it's not 1 over x plus 2 over y equals something. It's 1 over x plus 2 over y equals 6x minus y over t. I'm I'm not quite sure what you're asking there in that last message, unfortunately. Um, if the denominators have if the denominators have variables in them, you can still make it equal. We would just have to multiply it by something else. But let me show you over here what I could do, right? Like say here now, if I find the lowest common multiple of 3 and 4, or a number that both 3 and 4 divide into, evenly, right, I can get rid of the denominators over here. Like say, LCM of 3 and 4. Well, if I want to find that, I'm just going to do it over here as an aside. So 3 gives me 3, 6, 9, 12, 15, and so on. 4 gives me, I'm just listing out the multiples of these numbers, right? Oh, it's hard to see there with my hand in the way. Hey, that's 4, 8, 12, 16, 20, and so on. But we see that 12 is the lowest number in both, right? So since 12 is the smallest number that's in both a multiple of 3 and of 4, I can multiply both these sides by 12, and it's going to help me get rid of my denominators, right? And to answer what you were asking earlier, yes, the reason I can multiply by 12 is like you're saying, because the relative distance sort of between everything stays the same. Or if we look over onto this side, we think about it still as like a balance beam. If we took, say originally, right, these three black circles, were equal to the two black rectangles weights, right? But if I multiplied it by 12, like if I did 12 times as many, if I had 36 over here, and I did 12 times as many, I had 24 over here, it's still going to be equal, right? Because the proportion is the same. Don't know the answer with the after the equals, there is nothing behind. Um, Not entirely sure what you like. You can't. One of these things is here is like I'm not going to be able to solve this one. I'm not going to be able to get an answer in the sense that I can't get one number for x or one number for y because there's infinitely many solutions here because I have one equation and two variables, right? So I can't get a direct solution for either of these guys. But if I was to go through and to keep multiplying this out, what we'll see is even though I haven't really done anything because I've multiplied both sides by the same number, I'm going to end up getting rid of the fractions here, right? 24 over 3 is 8. 12 over 4 is 3. So now we see that these things are actually the same. Okay? Esther, so you're not able to chat through your computer, but you can on the phone. That might be because, make sure you're logged in if you're on the computer. Also, it could be the browser that you're using. Try updating your browser. Yeah, I know the Kevin. It's hard. It is hard to explain math online here. I'm going to tell you what. I'm going to write down exactly that one that you mentioned there, and I'll show you some stuff that we can do with that. So you said 1 over x uh, plus 2 over y equals, and you said equals had a question mark there. 1 over x plus 2 over y equals 6x minus 2y over t you had there. Yeah, this one. The problem here is that yeah, we can get rid of say that over t isn't it wasn't there. Okay, let's just I'm just gonna um I'm just gonna get the t out of there. That one made it a lot harder. But say we had this, like you mentioned in a message earlier, I can indeed get rid of the denominators on all these ones. It's totally capable of doing that because I now need the lowest common multiple of x and y. The lowest multiple of x and y is xy, right? So say what I was to do was to take this whole left side and I'm going to multiply it by x and y, like so, right? To keep this balanced, like over here in the balance beam analogy, right, where we added one green weight here, so we had to add one green circle weight here. The same deal over here, like I'm multiplying, or up here where I multiplied by 12, had to multiply there by 12. Here I'm multiplying by xy on the left, so I multiply by xy on the right. Right? So now, when I go through and multiply these out, we'll start seeing the way that I can cancel some of these, right? Because I'm going to end up with xy over x plus 2 xy over y equals 6x squared y minus 2xy squared, right? Now over here, this x and this x will cancel, this y and this y will cancel. So what I'll be left with, I'm just going to go up here with this, I will have y plus 2x equals 6x squared y minus 2xy squared. Now, unfortunately, with this example, this is kind of as simple as I'm going to be able to go here, right? Unfortunately, like I'm not going to be able to get away from the quadratic here, right, with the exponent 2's. But we can, as you see, we can get rid of any denominator and convert it into a form where we're not using fractions if we want to, right? And it all stems from the same sort of idea that an equal sign, in an equation, is the same as a balance beam, right? And you can just think, just with if you have something that is balanced, like perfectly balanced as all things should be, right? Thanos is not proud of me. I'm not super able to balance this. Okay, never mind. Never mind. You know what? Physical lessons are out the window. Never mind. Um, but yeah, things stay perfectly balanced as long as we do the same thing to both sides, right? Like imagine here, I was to um, double the weights, right? Over here. Now, say I was to double it. So now I'm going to add 4 more circle weights. Now, all of a sudden, this side is heavier because I've doubled the left side. Made that Thanos joke of physics when f res is 0. Yeah, there you go. When the yeah, when the remaining force is 0, exactly right. Yeah, when the forces all even out and nothing moves because it's getting pushed from both sides. That's exactly right. It's perfectly balanced as all things should be. Right, and the same sort of deal over here, right? Uh, If you double one side, you have to double the other to keep it balanced, right? Yeah, you're very welcome. You know where you can find more problems to solve? Yeah, absolutely. Um, I know it's sometimes teachers turn up their nose at it a bit because it gets recommended so often, but I do recommend Khan Academy if you're trying to sort of self-assess and see what parts you know and what you don't. Khan Academy has a very good sort of introductory quiz that you can do after you make an account, where you can go through and it'll start you off with some pretty basic math. But don't worry about that. That's the way it's designed, right? And if you ace all the really easy stuff, or all the stuff that starts you off with, it starts getting more and more and more complicated. And Khan Academy goes way up to like all undergraduate level math, pretty much, right? So there's a fair bit of stuff on there, so you're more than likely going to bump up against stuff that you don't know eventually in the assessment quiz. That's totally normal. Don't worry about that. Um, but and that's sort of the design of it, right? Is to find out which parts you know and which parts you don't know. And after you go through that intro quiz, then it'll start recommending different topics to you, and you can go on and pick topics on your own as well. But it is a really good way to point out sort of what parts of math you're strong in, and what parts of math you could use some practice on. Right, so that is a good site. Um, the first chapters of my old college book was really tedious, and I steamrolled through it. Yeah, yeah, that'll happen sometimes too, right? And like I said, the Khan Academy intro quiz is good at um, sort of showing you where you should be focusing. Right, it's a really useful tool like that. Yeah, I hope that helped you out. I'm more than willing to answer any questions you have, especially on good math fundamentals like that. Algebra fundamentals are super important for anybody, my students included, right? And yeah, that's the kind of stuff that I like to spend time talking about. So thanks for the questions. Just take a sip of water here. Okay, I'll get back to the questions for Renetta here now. Yeah, so to find one number as a percent of another, you just have to divide. right? So to briefly go back to question 6 for a second, because when I link right out of the video, I'll probably link it starting at this point. All we have to do to find one number as a percent of another, like in question 6, is we have to take the number and divide it by the original, right? Because we're asking for what percent did it increase by? Well, to find what percent it increased by, we need to know how much it increased, which was $1.50. Then divide by the original number, which was the amount that we had starting off, and we see that it increased by 12.5%. It's very frustrating. I lacked in math. I was able with physics to explain how deodorant works on a warm body with 8 thinking steps. Details for high school. You can mute the cannot talk because do not speak the language math. Yeah, yeah, absolutely. Math is completely a language. You're right. It is. Algebra skills are very similar to grammar skills. Yeah, they totally are. It's just another language with very clear syntax and rules. Yeah, just like English grammar or French grammar or anything like that. If anything, math grammar is kind of simpler and more regimented, right? Because it's language grammar has this sort of this weird evolution where it's like bits and pieces of like different times when nations conquered other nations and it affected their grammar and their language and their word choice and different languages combining and borrowing from each other and stuff. Whereas math is a lot cleaner, right? It does get pretty complicated, but the rules of math language are the same in English and the same in French and the same in Japanese and Chinese and you know every language in the world. The math is going to be the same, right? Whether we're taking algebra, I mean, it stems from al-Gabar, right? It was Baghdad is where it was invented, right? It was in Arabic originally that this sort of math was, but it's gone on, and changed and evolved, and it's one of the more universal languages that we have, right? Oh, you have dyscalculia. Yeah, dyscalculia, I think. This, yeah, it's that is a tricky one to master for sure, right? Because it's hard to have these I don't know these extra hurdles to face, but it's great that you're putting in effort to learn it, and yeah, I mean, um, I hope that I can help you as best I can, right? To master it for exact sciences, otherwise if I can't, it will go in history. Ah, history is a great degree. Tell you what, like when you go to university, in your first years, that's what it's about, man. I assume man, because everyone on the internet's a man. No, that's what it's about, right? When you go to university, first just take various different courses, right? Like you think you want to go into science, well, great, focus on some science, but also take a few other things. Do a history course or two. Do I don't know folklore or anthropology, or you take a major instantly. Oh, okay. Oh, that's good to know. Okay, so you have to choose right out the gate. All right. Well, you probably get some electives, right? And you can all. I imagine you could switch majors if you really wanted to at some point. I don't know exactly how it works. Um, but yeah, there's always like a good rounded education should have a bit of say the humanities to go along with some of the sciences as well, right? So yeah, I mean, I would encourage you to take a history course or two and just try it on for size, see how you like it. Let's see here. Question 7. I wanted to get on to question 7 in these ones. Uh, Sucks that I make my own chemical formula with molar calculations, but lack the math skills to do it with more complex systems. And then, hey, the math that's in chemistry is not trivial, right? You've got to, you can get some fairly advanced math in there. I didn't do a ton of chemistry. I did like 3 chemistry courses in university. Um, yeah, the math that's involved it's fairly complicated algebra, right? Because you've got to be able to master the multiples. One number says multiple of another, and see how you can simplify your formulas down, right? But it's all there's a lot of cross curricular stuff, isn't there? And this program that I teach is really good for that. I'm really able to point out a lot of the links between, say, the math that's done in a chemistry course and the math that's done in a physics course with the math that we're actually learning in the math, or there's always always trying to point out the links between the stuff, right? So getting used to noticing that will help you out greatly as you go through your education for sure. For number 7 here, just want to get onto that one. School trip to Japan. Karen spent the following amounts on souvenirs for herself: 900 yen for a keychain, 1,500 yen for a T-shirt, and 5,800 yen for a gold zodiac charm. How much did she spend in total Canadian dollars? All right. So first we need to find out the total number of yen. So obviously that's going to be. Won't hold you up any longer. Oh, don't worry about holding me up. No, no, don't think of it that way at all. I'm very grateful for the questions, because any math question that I answer around here, especially about the fundamentals and how algebra works and stuff like that, that's very useful to my students as well, and just anybody who's watching and interested in math. So yeah, thanks for the questions. So that's going to be 2,400 there, and that's going to be 78, 80, 82. Let me just, for some reason, I'm not trusting my addition right this second. It is 8,200. Whatever. You should always check, right? Like that's a good lesson. It's a good test taking skills lesson. Always check, right? But now I need to convert this 8,200 yen into Canadian dollars, into Monopoly money, right? So we're showing over here on the side these different conversion charts. Now, reading these conversion charts can be a bit of a pain sometimes, but it tells us that 1 Canadian dollar is 81 yen, or 1 yen is about 1.2 cents, right? But we can write these conversion factors in several different ways. But for example, from this first column, I know that 1 CAD per every 81, what's yen? JPY? Pretty sure it's JPY, right? So there's 1 Canadian dollar per every 81 Japanese yen. I'm just going to use 81, not going to use the 81.03. Actually, no, whatever. 0.03, contradicting myself. Look at this. Indecisive. Bully. But this is the conversion factor that we're given, right? And then I'm given 8,200 yen, and I had to figure out some unknown number of Canadian dollars, right? So at this point now, I can go ahead and multiply. Notice I'm always slanting up to the right. I think it's just the angle that I'm sitting at in order to get the camera and manage the shadows on my paper here. Anyway, so I'm going to take this and cross multiply. And we're going to have 8,200 on the left, and I'm going to have 81.037x on the right. Right? And then I'm going to go ahead and divide. You needn't necessarily do this way. Like, this is not necessarily the easiest way of doing this question, but to go back to what we were just talking about, actually, this is a really good example of fundamentals, because cross multiplying like this is super important in a lot of different courses that you're doing, right? And you're going to see this type of math, the cross multiply, come up a lot. So while there are simpler ways that maybe we could approach these questions, I really like teaching it this way, because this is a skill that you build piece by piece as you're going through these algebra skills to know how to do this sort of cross multiplying. And then in the later courses, when you have to use this, you already know it. Right? So I think it's a good sort of way of approaching it. Right? Another way we could think about it is with the sort of unit canceling, like I mentioned before, right? If we think about unit canceling, we know that we've got 8,200 yen. I'll use the different symbols here. We've got 8,200 yen, and our conversion factor is $1 per every 81.037 yen. And if we leave our units there, that helps us know how to arrange our conversion factor. Because now we know that our yen needs to cancel with yen, because we need to be left with dollars in the end. So if we multiply like this, we know that the yen on top and the yen on bottom cancel out, and we get our 8,200 over 81.037, because of course there is an over 1 over here that we just don't write out, right? And then that is going to equal the same as what we had down there, $101.19. I'll put the dollar sign afterwards, even though it's not normally how it works. Um, oh, the percentage formula is really nice. My formula, I hated practical chemistry and stock solutions, so I'm done quickly. As a substance fully dissolves. Coulomb's, yeah, Coulomb's law. That's right. Yes. Uh, yeah. N is the number of Avogadro, so you look at M as the mass of one molecule. That's right. Yeah. That is how you find the molar mass, isn't it? Yeah. Thanks. I'll uh, I'll drop you a line if I've got any questions about my about the chemistry work that I've got to correct sometimes. Thanks. Let's see. I wanted to do question 8. Question 8 is a quick one, and then question 12. Then we can get on to something a little bit different. Today I'm actually going to do a bit of a geography lesson on stream. Let's see. 8A. Convert 271 Canadian into US dollars. Okay. So again, like I'll use the cross multiply method like over here. From our conversion chart, we know that 1 CAD per every about 91 cents, 0.906 USD. We wish that's what it was now. Although I don't know about you guys, I ain't ordering a whole lot from the States these days. It'd be like that Simpsons joke where they get the package from Wish.com and the cloud comes out. Oof, oof, big oof. That's maybe a bit dark. Maybe a little bit dark. Now we have 271 USD divided. Oh, crap in a hat. 271 CAD per some number of USD. Oh, thanks for streaming. I have to go now. Thank you so much. Well, yeah, you're very welcome. Please, please feel free to ask any questions you like. And thanks for dropping by. Hey, Slayer Darth. Welcome back. It's good to see you again. Once we cross multiply here, we're going to end up with an x on the left, and then a 271 multiplied by 0.90601 over here. And then we're just going to have our number of Canadian dollars, Canadian Tire money. I wonder what's the conversion between Canadian Tire money and American dollars. That's asking the real questions. 245.53. I'm going to round to 2 decimal places because it's money, All right, sorted. Let me do 8B real quick. I'm going to use the same method, the cross multiply method, right? So we're going to have, there's going to be 1 Canadian dollar per every 81.037 Japanese yen. And that is going to be the same as, we're looking to convert 318 CAD for some unknown number of yen. Hey, Slayer Darth. Yeah, it's going pretty well. We're gonna have a little bit of a different stream today because after I get done this bit, I'm gonna do a bit of a geography lesson. We're gonna break out the Google Maps, which is fun. I like Google Maps. I can spend loads of time just goofing around on there, or like on GeoGuessr. Ooh, oh, maybe I should do a GeoGuessr stream sometime. That'd be fun. That's a great game. It's a good. It's like Google Maps, the game. Right, GIS. Yeah, I got several friends who did GIS as a degree. It's pretty practical. Apparently, they all got jobs out of it. Maybe that's what I should have done. 318 multiplied by 81.037. So x then is going to equal 318 times 81.037. There we go. That's going to be 25,769.77. Geography knowledge is pretty decent. Africa's a mixed bag. Yeah, I mean the Africa's big. Like Africa's huge. You know the like the Mercator projection that we commonly see on as maps really exaggerates the northern hemisphere and sort of minimizes the southern hemisphere. Like it makes Europe look gigantic compared to what it actually is, and it makes Africa look tiny compared to what it is. Yeah, it is. There's a lot of countries to remember. I mean, I can't even remember most American states, right? Like I don't know, like Missouri. Where's Missouri? All I know about Missouri is that Abe Simpson will be dead in the cold, cold ground before he recognizes it. Yeah, also makes the USA much smaller compared to Russia. That's true. I do know the names of the 50 states. I just don't. I don't necessarily. I couldn't necessarily point to all of them on the map. I I can get most of them. I would say. I'd say I could get a solid 46. I think, or 48 if we count Alaska and Hawaii. But those are gimmies. Like those are easy. Let's see where. What's next? Number 12. Wanted to do number 12. Complete the following conversions. Yeah, I don't think I need to do number 12. I think those are going to be fine there for the ones that I needed to do for Renetta. So hopefully that helped you, Renetta. If you've seen that, I will have. If you're watching this in a recorded video, hello, future Renetta. This is past Peter. Um, hope that was useful for you. Yeah. The Midwest is definitely the hardest ones for sure. Yeah. Um, yeah. I mean, a lot of like the coast ones are much easier, of course, right? But then there's just like the middle sort of flyover section. I do know which one Oklahoma is because Oklahoma is like when it's this way or this way, right? Then it's like Oklahoma, and when it's this way, it's good Lahoma, and when it's this way, it's bad Lahoma, right? I do know that one. Now let's see. Right. So I wanted to get on to talking about. Um, oh, stream is starting soon. Nope, it's already going. I wanted to talk about interpreting latitude and longitude, and then drawing line graphs. Okay. So let me bounce over here to the assignment that I'll be talking about. Okay. So this is the assignment, actually, that you're working on currently. Now, like I told you, the assignment is a little out of date because unfortunately that Wikipedia link doesn't work. But I linked you instead to the page a list of national capitals by latitude. So we're going to use that page instead. You're not necessarily going to get a city for all of these ones, but you're going to get a city for most of them. Okay. But first, I want to do a little bit of a brief intro to what latitude and longitude mean, right? So this is going to be Science 2100B. This is going to be latitude measures distance from the equator. Right? Yeah, I'm not actually going to talk about how to calculate them. We're not quite going to go that far, but I'm just going to talk sort of about what the definitions mean, right? So latitude is the distance from the equator. In or positive latitude means distance north. South or negative latitude means distance south. You notice that we're not talking about longitude. And the prime meridian runs through Greenwich in England, right? And that the longitude measures the distance left and right. Sort of left and right. What am I saying? East and west from that. Finally figured the difference between solstice and equinox yesterday. Yeah. So the solstice is the longest and the shortest days of the year, right? The summer solstice is the longest, and the winter solstice is the shortest. And then the equinox are in the spring and the fall, which are the days that's directly in the middle, right? Um, and a sort of halfway in between. It's not necessarily that you get exactly 12 hours of light and 12 hours of darkness, because of course there are places where, you know, where some parts of the year you'll end up with like 2 hours of light in the winter, or 2 hours of dark in the summer. And as you go further north, that's kind of what happens, right? For Ashley's assignment here, we're not actually going to need to worry about longitude, right? Because longitude are vertical lines around the globe, and they measure the distance, like I said, east or west from Greenwich in England. Uh, that's also where we get GMT, or Greenwich Mean Time. Greenwich Mean Time, like longitude, is loosely correlated to time zones, right? Some countries they're more accurate to longitude, like say in Newfoundland, we have a half-hour time zone, but that's actually very accurate to what the time actually is in, say, St. John's. I think it's like 3 minutes off what the time would actually be if we were going by exact longitude. Whereas a country like Brazil, which actually stretches further east than Newfoundland does, but is all on the same time zone as Ontario, right? It's a little bit, it gets a little bit tangly. Like 24 points in the Earth's core or something. I have not heard about that, but that is an interesting idea. I should look that up. To my knowledge, it mostly corresponds with latitude, but it kind of also corresponds with politics, strangely enough, right? Which is why South America, like I said, it goes further east than Canada, but its time zones are like all the same as East Coast USA, right? That's just one example of how, you know, time zones don't directly correspond. But latitude is what we're going to be dealing with, Ashley, in this assignment that you're working on right now. So latitude tells us how far north or south something is. And to show you a little bit what it's like, let me go over here to this Chrome window, and we see here now, this is the Northeast Avalon. Yes, my son, this is Newfoundland right here. This is the core of it, right? It's not the core of it, it's over on the side in it. But here's the island, right? So this is just on Google Maps. I've just gone to normal old Google Maps. And I'm going to show you on Google Maps sort of how we can see the latitude and longitude. Well, you see here if we zoom out, right? Let me see if I can see that again. Come on, where's the grid? Oh, that's a globe view. Globe view is really good. I do want globe view. Yes, that stops the issues with the projector. But there's actually lines that run. If we I should have checked on how to get that to pop up before I went doing this. Oh, Google Maps does not have permission to use my location. Great. I'm going to keep it that way. Okay. But the lines of latitude run sort of this way, right? They run horizontally around the Earth like this, and it measures the distance north or south from the equator. Now, the equator is this line here. So the equator is a line of 0 latitude, right? So it's right in the middle of the planet. That's 0 latitude. You can see here it goes through South America, it goes through Africa, and it goes through Southeast Asia over here, right? But for us now, all the locations that we are at in Canada up here are all going to be distance north because it's all north of the equator, right? So if I zoom back in on the island here and back in down near work, we see, over here, this is where the school is, right? So if I click there, I see a number pop up down here in the bottom. And you see this? See this here? This number is a coordinate, right? This is latitude and longitude, right? So we see here now that I'm, showing the world where I work. Oh boy, um, but down here, this is the latitude and longitude. So we see it's 47.5 north. 47.5 north shows how far we are from the equator, right? And then the other number shows how far east or west we are. Now, we're not super concerned about those right now, right? Now, it's kind of small on your screen there, but you can see this is the latitude and longitude. So 47.5 north, that shows how many degrees, and it's measured in degrees of the planet's surface, right? So it's not an actual, it's sort of a percentage of the total possible distance north, right? So let me pop back over to the assignment for a second here on the document display. We see that it's asking you to find an example of a city that's that's about 90 north, about 80 north, about 70 north, about 60 north, and so on. Now, unfortunately, the list of pages of cities that you're going to use for this activity actually are don't necessarily contain a city on each one. Let me switch back over to Chrome here. I'm going to show you how to use this page to sort of solve the assignment that you're on, right? So this is list of national capitals by latitude. And over here we see, so this is the name of the cities, but by default, right, from the start, we see that this is in alphabetical order. Now, alphabetical order is not super duper useful to us because we're not concerned with the names of the cities. We're concerned with the latitude and longitude. So what I'm going to do is I'm going to go over here. See this thing? It says sort ascending, right? Oh, you can't see you can't see my tooltip. Oh, weird. I didn't know. I didn't know that OBS wouldn't capture my tooltips. Interesting. But over here, if you mouse over this part, I can see it popping up saying sort ascending. So I'm going to click there. It's kind of confusing, sorry. Yeah, if you're finding something confusing, yeah, you can let me know. I am gonna sort of breeze through some of these parts pretty quickly. So over here now, I've clicked and I've sorted these in descending order, right? So from here now, you can go and get some cities that correspond roughly to the east of the poles being negative and west of the poles being positive. Yes, yeah. So yeah, for latitude or longitude rather, for east and west, west of Greenwich would be negative, east of Greenwich would be positive. Yeah, and of course you could measure either way, right? Because if you keep going east, you're going to loop around and get back to it anyway, right? But we usually take the one that's the smaller of the two numbers, basically. Yeah. For this activity, though, we are concerned mostly with latitude, right? So, say for your sheet over here, we see that Longyearbyen. I'm not my Norwegian is not very good, but if we click on here, right, you can see it come up as the largest settlement, the administrative center of Svalbard, which is Svalbard is this. See this here? That little guy, right? So it's all the way up here. Yeah, there it is, right? You don't need to find it on the map. I just wanted to show you on the map where it is. So you see that 80 degrees north. 80 degrees north is practically up to the North Pole. You'll see there is no North Pole here, right? Because the North Pole is just ice. There's no land there. The equator is known as a parallel. Yeah. I mean, the equator is we would call it the zeroth parallel, right? We could call it, right? Just like right, kind of like how the border between the U.S. and Canada, this unmarked land border here, we call this the 49th parallel that stretches across here because that's what this border, the border between USA and Canada, from sort of from Manitoba west, right, is the 49th parallel. So the 49th degree of latitude. South of it is the States, north of it is Canada. The longest undefended border in the world. I mean, for now anyway, until Donnie sends his troops up to patrol the border or whatever. But I'm gonna try real hard not to get into that sort of stuff on stream. But anyway, if we flick back over, we see that this Longyearbyen, right, is about at 80, right? So if we go back to your assignment, you can fill that one in here for 80. Now it asks you for mean temperature for a date. How are you going to get that, right? So I'm just going to write this out here. So 80 N, we can say long year bien, Longyearbyen, right? And then we'll say over here I'll have mean temperature. We're just going to pick a date. Just going to pick a date. But what I'm going to do to find this, now, the fact that we're on Wikipedia here for this activity is really useful, because now you're just going to click here on this one, and you're going to come up with the Wikipedia article for Longyearbyen, or whatever city you're clicking on. You can scroll down then till you get to this part. This part here, this climate data, super duper useful, right? Because I'm going to get the mean temperature for, let's just pick this month, for May. So I'm going to look over here. I see May right there, right? This is record high. That's not what I want. I want daily mean. I want this one here, right? So the mean daily temperature for May is -5. Holy moly. I mean, it's bad enough here, right? What's the mean temperature for like Newfoundland in May? Probably 7 or 8 degrees, maybe less, right? But -5 to be the mean temperature for May. That's woof. Yeah. Svalbard. That's an interesting. You know, it's illegal to die on Svalbard. That's true. It's illegal if you die there, you will get sued. No, if you die there, your because the permafrost and stuff doesn't decay, your body actually has to be shipped out of the archipelago to be buried. It's actually too cold there for bodies to decompose if they're buried in the ground, which is yeah, it's an interesting spot. It's the kind of spot I would like to visit just to say I was there, right? Apparently, I've heard that it's illegal to lock your cars in Svalbard because there's so many polar bears there and they're all very hungry and people look like snacks. That it's illegal to lock your cars because people need to be able to hide in them. Yeah, it is illegal to die there, right? That's good. It's a good soundbite to say it's illegal to die someplace. Again, I'm going to go back to this activity, right, to this page. I'm going to sort it, click there twice, and it'll sort by descending. So now let's get one that's about, yeah, I see one here that's about 60. There we go. So about 60 north. I can pick Helsinki. Helsinki, Finland. That's another place I'd like to visit, too. I hear Finland is gorgeous in the summer. So if I click here, right, I can bounce over here, scroll on down. Then we get this. We're going to get the daily mean for May. Daily mean for May for Helsinki is 10 degrees. That's warmer than I thought it would be. That's rather pleasant, actually. 10 degrees is the mean. Now let's not going to do the whole activity for you, but I am going to get a few data points because I want to graph them. I want to show you a bit about how we're going to graph these things. So let's go back over. Let's get a few more. So I got one at 60. Let's get one at around 50. What's good for 50? Prague. Oh, there we go. Prague, Czech Republic. Yeah, Prague will be relatively cold for its latitude. Although London will be really warm for its latitude. I'll pick Prague. I've been to Prague. Now we're getting to cities that I've been to. I haven't been to Helsinki or Svalbard, but I have been to Czechia or Czech Republic, whichever one we're calling it. Now let me scroll on back down here. So let's get the mean temperature for May. Daily mean 15. 15 degrees C. All right, I'm going to get a few more data points here so that I have some stuff to graph. So then actually I can show you a bit more about how you're going to finish the final part of this activity. Let's go down now. Let's get a capital that's around 40. Oh, Beijing. Beijing in China. There we go. So 40 in. Beijing. I'm going to click on this one. Let's go down and get the. That's quite the shot, isn't it? Beijing would be a nice city to visit. Maybe not right now. I don't know. Like I would love to visit China, but at the same time, like not super wild about their. But anyway, I'm not going to get into politics. Not going to get into that. Oh, where's the climate section? Oh, there's no climate section on this one? Oh, weird. Usually there's a climate section on all of these. All right, maybe. Oh, no, here it is. Average summer temperature. Oh, that's really too bad. They don't have the same type of info there. maybe the information out of China is not as complete as out of some countries. I don't know why they wouldn't have weather though. That seems a bit odd. So let's pick a different city. Let's pick Madrid. There we go. I also have not been to Madrid. I would like that's one I'd like to see for sure. I bet this one's going to be warm. This is going to be a scorcher. Oh, okay, not that bad. Daily mean 17. So 17 degrees Celsius, daily mean for Madrid. I'll get one more data point, so I've got 5 in order to show you the plotting. Got to go back over here, got to rearrange these guys by descending order again. Let's get one for 30. 30 Cairo. Nice. That'd be a place to see. Yeah, Cairo would be fun. And that one is going to be warm, I bet. Daily mean in May, 25. Yikes. 25 degrees Celsius, daily mean. Okay, I mean, it is in the, it's in the desert, right? It's like the most fertile desert in the world, though, right? The Nile Delta. That's a nice, latitude is the distance between a parallel and the equator. Longitude is the distance between a meridian and the prime meridian. Exactly. That is, yes, Slayer Darth. Yeah, you're exactly right. That is what it is. Oh, 2 new cases today, Esther. Oh, that's unfortunate. It's always unfortunate to hear of any new cases, but we're keeping the numbers nice and low. This makes what, like 4 new cases in the past 2 weeks or so, right? So that's not very bad. It's I still think we're doing really well, but we're gonna get some blips sometimes. You know, as long as we're doing a lot of testing, I'm pretty happy with that. Right? So now I've got a few good data points here that I've copied out. Right? So I've got my Longyearbyen, because we're slim pickings when we get this far north. There's not very many capital cities this far north. We've got Helsinki, we've got Prague, we've got Madrid, and we've got Cairo. Right? So now what I'm going to show is a little bit about the next activity, which is the graphing. Now, unfortunately, I don't have any graph paper here to do it on, right? So I do recommend, like I always say, for you to use graph paper and not to use just freehand like I'm going to do. But I am going to do it freehand here because, this is the resources that I have available, right? Introducing physical geography. Okay. Yeah, that does sound like a good read. Yes, I will check that link out after I'm done here in the stream. Now I do trust you, Slayer Darth, and I can see what that link is. I'm just gonna say, to other people in the chat, in general, it's not great Twitch etiquette to click links that people put there, but I think this time we see it's an Amazon.co.uk link. We're totally fine, right? But just telling you, because I know some of my students are maybe their first experience with Twitch might be watching this stream that their teacher recommended, right? But now what I'm going to do is I'm going to graph these things out. Now, across the bottom here, I'm going to call this one left and right. I'm going to call this latitude here. And down the side here, I'm going to call this temperature. Now, it is really important to have temperature be this one here, right? Because for what we're graphing here, latitude is the independent variable, temperature is the dependent variable, right? Right? So temperature depends on latitude. So temp needs to be the y value, latitude needs to be the x value. So I said I'd bring it back to math, right? We got there. We got there in the end. This is now back to being a math lesson because the dependent variable is the one that depends on the other one, right? So the latitude doesn't depend on the temperature, it's the other way around. The temperature depends on the latitude, right? And we'll see as we go through here that it does indeed, right? Now, I do want to show, one reason I wanted to graph this out is because I wanted to show the fact that you are going to have positive and negative temperatures. Because as you notice, right, for our Longyearbyen over here, it was -5 for the mean temperature for May. So we are going to need to be able to go below 0 for temperature, which is why I've extended this line above and below, right? So I'm going to do what I normally do. I'm going to mark off some lines here, some gradations. I'm going to do a ½ centimeter each one. If you're using graph paper, of course, you can just use um, the blocks as they're drawn, right? I'm going to have each of these blocks represent 5 Celsius. So that's going to be 5, 10, 15, 20, 25. So like that. Actually, no. We're going to be a bit small. It's going to be a bit small if I do that. I'm going to have 2 blocks represent 5. So it'll be 5 there, 10 there, 15 there, 20 there, and 25 there. And this is going to be -5, -10, and so on down that way. Don't mind what I just drew there. First, I want this to be big enough for you to be able to see what I'm doing on the camera. Right, and now for latitude, I'm going to do the same sort of thing. I'm going to mark off every, say, ½ centimeter or so. Now the latitude, oh yes, you're going to need to go over this way as well. Right. Okay. Okay. This is important here now. So I need to go grab another data point or two because I need to show you what's going on with negative latitude, right? Because we are going to have to go over here for negatives. I'm just going to graph these first few, then I'll go grab a bit more info and graph the rest, right? So to show you here I don't have a camera set up to show 2 pieces of paper at once. Maybe I need that. Maybe I need a scene to be able to flick to that gives me a bit more space there, like so. So now I'm going to graph these first ones. So at 80 north, it was 10 degrees. So I'm going to have each of these blocks represent 5 degrees in latitude. So this is 10, 20, 30, 40, 50, 60, 70, and this other one here will be 80. Right? So when we're at 80 north, or 80 positive, our temperature was -5. So I'm going to put the dot down here, right? So I'm using this as like a carpenter square. You won't need to do that when you're drawing it out on graph paper because you'll have lines going across. But we go to -5 to 80, and we put a dot there. And I'm even gonna put out the name of the city next by it, right? This is Longyearbyen. I hope I'm saying that correctly. I don't know if we got any native Norwegian speakers in the chat. So the next one we've got 60 north is Helsinki. So at 60 north, it was up to 15 degrees. So I'm going to go line up this side of my square on 15, line up this part here on 60. There we go. So there's going to be our dot there. This one's Helsinki. Okay. I'm just going to keep doing these ones. So 50 was at 50. Oh, Helsinki was 10. Never mind. Never mind. I was messed up there. Helsinki was 10. Okay, so don't mind what the teacher is doing. He'll figure it out eventually. It's just because my writing was slanted over there. That was the problem. Okay, so Prague is 15. Prague is 50 north and 15 degrees Celsius on average. So we put a dot here for Prague. Then we're going to go Madrid, 40 north and 17 degrees. Madrid's going to be there. Cairo, 30 north and 25 degrees, right? So Cairo is getting kind of warm. You can already see, right? So we can already see some evidence here of what's happening, can't we? Right? Because if we look at our graph, we see that the larger the latitude, the colder it gets, right? Which makes sense because if the latitude is a large positive number, we're going further north past the equator. And as we know from living in Canada, the further north you go past the equator, colder it gets. Maybe you do that from anywhere, but I'm just saying, relatively cold. So let me skip a few, and I'm going to pick some of the southerly ones. You notice over here on the document. Oh, you notice over here on the document it says 0, 15s, 30s, and 45s. What we're going to do off the sheet that you see here, or off the website rather, that ones are going to be represented as negative, not as s. But a negative or a south means the same thing here, right? So let's say I pick. Let's get one for. Let's go for 10 south. Let's see. Some of these are fairly small. Oh, let's do Jakarta. Jakarta, that's a good one. So this is going to be about 6 south. Jakarta in Indonesia. That's a place I've never been. Never been to Asia actually. Never been outside of Europe and North America. Now let me scroll down here. Let's see what Jakarta's average May day is going to be like. Average May day in Jakarta is going to be 27. That's a scorcher. But it's about the same as Cairo, right? Let me go back to my list. Let's go a bit further south, right? So La Paz. La Paz is going to be an interesting one, right? Because La Paz is further south, but it's going to be quite a bit colder than it would be for its latitude because of the elevation. La Paz is very high uh, in a mountain plateau. Let's see. Let's get yeah. Let's try this one. Port Louis. So this is going to be what was that? Was that 20s? That was about 20s, right? And this one, the oh they have a record high, an average low, and a record low, but they don't have a. That's unfortunate. They don't have an average in the middle. I'm going to assume that I'm going to pick halfway between the average high and the average low. This is really too bad when we've got side examples here of where it doesn't quite pan out the same as the rest of them. So I'm just going to pick that 20. Oh, I was gesturing as if you could see 25.4. So anyway, these are some southerly ones that I've got here over on my document display. So I've got Jakarta and Port Louis. So I'm going to go back to my sheet over here and graph those. Right? I know this one's it's a little bit different than the other activities that I've been showing on here, but hopefully this is still giving you a good idea of how you complete these guys. So 6 south is going to be over here, right? So at 6 south, it was 27 Celsius. So that's going to be over here. And this one is Jakarta. And then at 20 south, it was 25 degrees about, and that was Port Louis. So let me join that one up. Dot there, like so. Let me get one more. I want to show you sort of the conclusion that you should be seeing here. So let me get one more southerly one. Back over here on the Chrome page. Boy, this one's a workout for my scene changing. Let me pick one that's fairly far south. Santiago. There we go. Nice. Good choice. I would like to go to Chile as well. That'd be fun. Yeah, this is what I wanted to see. Good. Thanks. Thanks for coming through for me, Chile. Uh, so Santiago. Now this one's mountainous as well, so it's again, right, like a lot of the cities in South America are in very mountainous areas, right? Not the Brazilian ones, but most of the other countries, at least the ones on the western side. So the daily mean is going to be about 10, right? So if I go back over to my document display, right? Santiago was that negative 20? I'm balancing a lot of different stuff here now. Santiago is negative, was about 30, 33 south. So Santiago was a ways down. So let me now bounce back over here, right? So I've got 10, 20, 30. So this is negative 30. So Santiago was 33, so it's a little bit more than that. And it was 10 degrees. So 33 and 10, it's going to be about here. Santiago. And now we're starting to see the conclusion that I'm going to be looking for you to get, and sort of the rough way that I'm going to be looking for your activity to draw out. Now I have gone through and done a lot of the work here, but I mean you'll still have to do up one similar to this yourself. And now what you can do is you can take it with a line and just join these guys up. So I'm going to start joining these points together here. Now I didn't get as many cities as you're told to get for this activity. So when you do it, you're going to need a few more. Maybe I'll yeah, in the efforts of making this look more like it should, and because a nice geography activity is kind of fun, let's get a city, let's get one that's around 0. There we go. There we go. Let me switch on back over here to my Chrome window. Let's pick Singapore. That's another city I'd like to go to. And it's like you can do the hard and firm bit. Singapore? Oh, I think I sang it pretty good. That one's too rude, actually. That's too rude. This is a G-rated stream. I can't actually do that bit on stream. The offensive, hard and firm, offensive vaudeville jokes. But it's great. That's a real gem. It's a real gem of a comedy bit. So this is so Singapore is about 1 north, so very, very, very close to the equator. And Singapore's, let's see, where's that chart? Oh, we don't get that nice little chart. That's too bad. Let me see here. There should be a climate section. Climate here. Oh, it doesn't. That's too bad. All right, well, let's go back and find a different one then. Sorry, Singapore. Kampala, Uganda. Let's see. Does this one have a chart? It does. Okay. So about 0 north, Kampala. And that one in May, the daily mean is only 23. Okay, that's odd. Yeah, maybe it's to do with local geography. Let's pick one that maybe has a more expected result. Although, I mean, if you get an unexpected result on this activity, that's totally fine. There's loads and loads and loads of cities in the world that won't have their climate based directly on their latitude, right? I'd like to bring this up a lot, actually, because in Newfoundland that's super relevant, right? Because our latitude, we would actually be fairly warm if we had if the latitude was what mostly determined our temperature here, but it doesn't, right? Because it's the ocean currents. Because our latitude is roughly the same as like southern France, like Nice, right? And Nice is has gorgeous Mediterranean climate, and we've got like wind, rain, and bullshit. Anyway, the climate here is not so bad. It's just really the amount of cold rain sort of grates on you. November drags on, but once it gets into proper winter, it's nice. So we've got about 0 degrees north of Sao Tome. I think that's how you pronounce that. And that temperature is going to be about 26. So nearing the end of showing the example of how to do this one. Now, this one's dragged on for a little bit, but I'm having some fun doing something a bit different. So now I've got it around 0. It was still at about 26. So that was SA Sao Tome. Right? I'm just going to go through and join these guys up, like so. Right? I'm just going to join each line to another one. And this is the kind of thing that you're going to be doing as well. Okay, pretend I can draw lines accurately. Just, just bear with me here. But you'll see, once we get down through this, you'll see that it's going to form sort of like an N shape, right? The further you get from the equator, the colder it's going to get, and around the equator, it's going to be pretty warm. Now here, like I said, depending on what city we pick, there can be a massive amount of difference, right? Because say London, England, is further north than St. John's, Newfoundland, but London is a solid like 15 degrees warmer most of the time, right? And it's because London is warmed by the warm waters of the Gulf Stream coming across the Atlantic, whereas Newfoundland is cooled by the cold waters of the Labrador Current coming down, right? Which is a topic actually in the same course that you're working on right now, right? So that is good for you to know as well. But then, yeah, I know that was a little bit of blathering about that topic, but actually, hopefully that will help you see a bit about how to solve these ones. I will send you these notes as well, right? So, yeah, that's everything that I wanted to get to today. Thanks for sticking it out with me, being here for another day of online teaching, of distance offsite teaching, right? Yeah, we got some good stuff done. Thanks very much for all the questions submitted today. Very happy to always be helping people out as much as I can. Right? Yeah, I'm going to leave you again with this wonderful picture of little furry Smokey being a very good dog and getting right in the way whenever you're trying to do anything. Right? Anyway, yeah, thanks for being here with me, and have a great rest of your day. Stay safe, and I hope to see you again tomorrow.